DevNexus, and I'm sitting down with Sean Phillips, and he's going to talk about us the topic of his keynote. So tell me,
Okay.
we've already had this conversation, starting this conversation, and I was saying like I know you since some years ago,
That's good.
and before you were literally working for NASA. So if a person would have said that this is not rocket science, that actually only applied to you. At least that was my perception at the time. But you were telling me you changed jobs.
Yeah, well, I mean, before I worked on a lot of NASA ground systems, I was a software engineer that worked with the mission design people, worked with the propulsion people, worked with the science people, and made sure that their ground systems, even their onboard software worked properly, right? And that was good stuff. I did a lot of deep space stuff, and I guess I got a little bored. And so I know it sounds like really, really, like how could you say that? But like after doing it for eight or 9 years, I decided that I wanted to do something different, but I still wanted to do visualization work. So I changed my position. I now work for the Johns Hopkins University Applied Physics Laboratory, APL for short.
APL.
And in my group, we do a lot of work with data analysis and machine learning.
Okay.
So one of the things I do is make a lot of custom high-performance 3D visualizations to support the various data scientists trying to get their work done by providing them with interactive visual tools that let them analyze not only the data, but the models, how the models perform, and that sort of thing. In the keynote, and I'm pointing at the amphitheater, is going to be this concept of real-life neural networks, i.e. your brain, which have inspired artificial intelligence neural networks, AI, okay, and then the tools that have been developed to analyze AI, then being turned around and reapplied back to actual biological neural networks.
Oh my, that sounds like incredible.
Well, I appreciate it. And really the presentation is just that cycle, but captured as a three-dimensional visualization tool that I built for that.
Okay, and does it match? Because sometimes I have read that how do we think our brain works? Like, how do we model the different layers and the networks that we create? It was an abstraction that maybe it was not like 100% fitted. But now that you close the circle, you close the cycle, you are getting more feedback that I cannot honestly even imagine the amount of feedback on that information.
Well, it is a lot, and let's be clear, we as a research community have only just scratched the surface. And I want to be very clear, I'm a software engineer. My specialty is moving pixels around. and I do it really fast, and I'm really good at that. But my job is to make sure that the people who are the actual neuroscientists can actually do the research as effectively as possible. So they're the ones that are doing this amazing research. And so I want to make sure that credit goes out, right?
Sean, we still need to understand the domain. I mean, this is something that we always discuss with software engineers. We not only software engineers, we need to understand a little bit of the business logic.
It's true.
Your business logic is amazing.
I tell people, I do believe this though, when people say, well, how hard is software engineering? I tell people it's kind of the hardest, it's pretty much the hardest job that there is in terms of like technical careers, because you have to not only be a master at your field, but then you have to become a master at somebody else's field every 6 months. Every time your project changes, you have to now learn somebody else's job, and you have to do it well enough, you have to learn it enough so that you can then make it easy for them.
Exactly.
But it took them years to get to where they're at. And so when you're constantly learning new career fields every other year or whatever, I mean, there's a lot of, it just becomes, that's a lot of pressure, that's a lot of effort, yet we just do it.
We have to, and that's something I really love about software developers. We have to see the abstract level.
Yeah, exactly.
We need to learn how to learn,
Yes.
Because our work, it's about changing so much. Domains, technology, strategies, paradigms, architecture, everything changes.
Right.
And this is one that actually changes super fast.
Yeah, you're right.
So tell me, like any more sneak previews
About the keynote.
about the keynote?
Well, of course, for you.
Okay,
All right.
thank you very much.
The inspiration for this software came from a project that my work, the APL ran, which was called NEO. Mm-hmm. NEO stands for Neurally Enhanced Operator. Okay. Now, I can't share all the details because of the sensitivity reasons, but we actually worked with several other universities, and we had a human subject that had an actual brain-computer interface surgically implanted inside of his brain.
Wow.
Yeah, wow. And he would come in the morning, and they would plug in actual electrodes into his brain with all these pins, like think like a VGA cable or whatever, except that instead of 15 pins, there's 300 pins or 1,000 pins, and boom, 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 boom. And then my job was to make a visualization that was interactive, that they would literally have in front of him, and he would sit there plugged in and not only manipulate things on the screen with his brain, he would receive information and then have to make choices based on what he received. And then the neuroscientists who not only did the surgery, but also understood how these things work, they had all kinds of different experiments to try to test how fast he could react, how much of a signal could he receive, what could he do with signals coming in and also doing other normal motor activity at the same time. And these are things that nobody knew the answer to.
No, because we haven't even figured out how our actual neural networks are connected.
Right.
I think it was recently in the news that we were able actually to map the connections from a larvae or something like that.
Something much simpler.
Yes.
Yeah.
But
so to be fair, the human brain is just it's incredibly complex, and so even with these electrodes, they're only looking at a very small subsection of neurons, and even that was grossly complex to the point where we needed very special dimension reduction type math to even decode it. And what we found, here's a sneak preview, is that, you know that movie Pacific Rim where they're in the big robots and they're neurally connected?
Two people,
but then they drift away, they slide away, and everything gets screwed up? That's exactly what was happening. They would train their decoders in the morning on how his brain activity was operating that morning. And then the next day, his brain had slid from the decoded state.
So they need to refresh.
They had to retrain every single morning, but that training process took over an hour, and they only had him for 5 or 6 hours a day. So when you're spending almost 20-30% of your time just retraining, that's a loss. That's a lot of resources that you're losing out on, right? Because it's just this person's a one of a kind person. There's nobody else in the world like him. So we accepted that as part of the challenge. But then at the end of all that, I was reading some papers and I thought, no, we got to get better at this. But we don't know why we're not getting better. So when you don't know how to solve a problem, one of the best ways to understand that and explore it is through visualization. So I made a 3D viz, which showed how when the human subject did a certain activity, made a motion with their hand that we'd asked them to do, how did the brain react?
Yes.
And what we found, and we applied some math to it that I barely understand. Like I know the 3D stuff, but like the actual math is like voodoo to me. But what it showed was we were actually able to visualize in 3D using JavaFX how the trajectories of the neural pathways firing, essentially how they were changing from day to day. We found that it was actually a very similar shape. It's just rotated in space. And so the reason that decoders were failing was because they were being trained on an arc in 3D space, hyperdimensional space, that maybe looked like this, but then day 1 it's like this, and day 5 it's like this, and day 63 it's over here. But it's the same shape.
Yes.
And so what they really needed to do was transform it into and then look at it as a pattern, not as a specific set of numbers. But by then the program had completed. I was doing that as an internal research and development thing. So now we had this like kind of like one-off visual capability that proved that you could look at hyperdimensional data effectively in 3D. So we kind of stepped back and we're like, well, what else could we do with this? And somebody who was working on artificial intelligence models, overhead imagery, recognizing objects, said, well, can you do that for my hyperdimensional data? Because that's what an AI model is.
Because at the end of the,
it's the same thing. Yeah, right.
Yeah.
Vectors of vectors, matrices of floating point, and it freaking worked. Like it just like the same visuals really worked well, and I just kept building more and more features to help out the AI people, and then a year had gone by. One of the other neuroscience people had come back and talked to me and said, "Hey, remember that visual that you made on IRAD? Well, we got this new research, brain-computer interface research program. What if I gave you some of the data we collected? Could you plot it for me?" But by then, I had built so many other tools for AI that we had not tried any of those new tools on this old stuff, and that's what you're going to see in the keynote. It's coming full circle. We go from natural intelligence to inspiring artificial intelligence to developing the tools necessary to analyze that to then applying those to understand our own brains yet again. Full circle. And that's what you're going to see, but you're going to see live software demo in 3D.
Oh my God, now I don't want to miss it.
Well, I hope. Let's pack that friggin' theater, you know?
Yeah, no, it's going to be, I mean, what you have described right now blew my mind because it's a lot of, honestly,
well, we better hook you up to the software then,
you know? Please. No. It's because humans really like to recognize patterns, but what we are not so good at visualization. Yeah. So how do we visualize even the trivial stuff in a 3D space? It's completely complicated. And
yes.
Now we're talking about even more dimensions.
Yeah,
So
12, 24, 512 dimensions. Yes. Yeah, so we have techniques. And so at the end of the day, the visual renderings are still in 3D. It's just that it's how you organize the data and how you associate data together with other bits of data and how you give controls, interactive controls, to the user so they can quickly and easily not only switch between different dimensions, but also understand the context.
Exactly.
That's the beauty of this tool because, yeah, we've got some 3D surface renderings, we've got some 3D scatter plot stuff, and we've got some 3D trajectories, but it's not like that's new. Other people have done things like that in the past. It's the new part, and this is the thing that really says Java, is that you've got to manage all that data and all that information behind the scenes, and you've got to. It isn't useful for a couple dozen data points or a couple hundred data points. It's got to be like hundreds of thousands of data points just to even get started. And it's not just hundreds of thousands of data points in one direction. It's also hundreds, if not thousands you've got a very long and wide problem, and you're trying to then roll it together and then display it in 3D, but then also have it so it makes sense. Like it's got to be fast. It's got to be straightforward. You put Java effects together with Java.
And it has to be beautiful.
Well, it does. I mean, yeah, no. If you're going to explore a problem space visually, and you got to stare at that, it's got to be beautiful because it is the problem.
Yes.
The pixels become the problem. So it's got to look good.
It's a representation of the problem,
yeah.
and we need to stare at it, and we need to find this moment where we, in a way, identified.
The aha moment.
Yes, exactly, because by like that happens a lot with the human brain, but you need to have like this pattern first emerging, and then what disturbs the pattern, and then you get like the difference, and our brains does that so fast that sometimes we don't even realize our thinking process.
Yes, and actually, another problem on top of that is it's our human nature to interpret information that we see a certain way because we've evolved over a million years or whatever to see things a certain way, but the evolution that we have, and I'm not an evolutionary biologist, this is just total layman's understanding, but we evolved to survive.
Exactly.
We evolved to not get eaten, right?
Exactly.
But that's not, these problems are completely different from that, right? And so the way that the data is presented
matters.
It matters because it has to tap in to the things that our human brain have evolved to recognize, but it also has to be correct. It has to be precise.
Exactly.
And so that's one of the challenges that I had with this tool.
And the other thing is, what I understand by your description is you also have to consolidate a lot of data
Yep.
and try to give it a different meaning,
Yep.
but in the same space that it's being going to be represented.
Yes.
And
Yes.
allow the people manipulating the different tools have this access and discerning how actually all these different patterns or different consolidations or different matches or groups actually are.
Yes, yes, absolutely.
I love it.
There's several different 3D projections that you can see. They're like sub-tools. So we have a 3D surface where it takes all the data points that you have in time and also all the width of the hyperdimensional vector, the width. And then instead of treating it like one big incomprehensible blob, it unrolls it and then lays it out as it looks like a landscape. And then you can enable these controls where you can hover over it with the mouse, and it tells you precisely where you are and what the numbers are, what the minimums and the maximums in the rows and the columns are. And so these are very generalized tools that you might think, oh, yeah, I've seen something like that. Like I know MATLAB, you can do that in this, and Matplotlib in Python or whatever. But okay, now do that for thousands and thousands of points, and do that in 3D, and do it so it's useful.
Exactly.
And it's like suddenly, a lot of these other tools, they just don't get the job done. You need a custom tool, and it's got to be fast. It's got to be pleasant to work with. It's got to look good, and it's also got to be inspiring. And I'm saying that I'm not trying to be pretentious. It's just if somebody doesn't want to use your tool, they're not going. That you already lost, right? And I don't want to name any names of tools that maybe we have to use but we don't like. But they're out there. I have my opinions, but.
Yeah, no, but I'm actually like that you are in this way proud of what you're creating, because what you are doing right now, it's not trivial. It's not easy.
No.
We have talked a lot about user experience, user interfaces.
Yeah.
How do we make the basic rules? And sometimes in some project we still see oh, you're adding. Where is the delete button? Do we need a delete button? And you're like,
that happened to me that happened to me last week. I had a guy. There's a couple guys that are doing some advanced research using some of the OpenAI large language models, and we have some internal servers. I'm actually going to talk about it. We have that cross-reference images and text and documents and stuff, and you can do like a Google-like search, except it does all the cross-referencing using AI on the back end. And they're trying to visualize the results in this software, which is called Trinity. Neo Trinity. Right? Yeah, I know, right?
Cute.
Yeah. I hope I don't get sued by whoever, Warner Brothers. One of the things it does is the software, it tracks all the labels that are in the data. So it can tell you, of all the data, we've identified 6 or 7 different types of labeled data, and here's how we're going to color your points based on those labels, right? And then you can change the colors and stuff. And what they were doing was they were like, oh, let's try this data set. Now let's try this one. They're drag and drop and drag and drop. And it's like bang, and then they clear and they do it again, except I never cleared the labels. And so after 15 minutes of them just trying different chunks of data, and they had like 100 different labels in this huge list, and they're trying to find which one is in the color. They weren't sure which colors were what, and they're like, okay, how do we clear the labels? And I'm like, you close the application and restart it? I never thought of it. There's so many little things in a user experience like this, and the problem is, if you try to do everything, including the kitchen sink, if you try to do it all up front, you're going to fail.
Yes, of course.
Because it's too much, and it'll be maddening. And also, frankly, what are the odds that a software engineer who has a good idea is going to get it right, such that all the people that might use this tool are like, yeah, that was good. I don't know exactly what they want, because I'm not them. So it's better to do these things a little bit at a time, but then the caveat, the problem is exactly what you said, that there's no delete button. I literally didn't have a delete button in terms of labels. So I just added that last week. so that I'm able to actually give this presentation. There's a couple things. There's actually, I finished some work on something last week that it's something called UMAP, Uniform Manifold Approximation P. I don't know what the P stands for. It's a process for dimension reduction, and it's used a lot lately in machine learning to go from like hundreds of dimensions down to maybe 2 or 3 or 4 or 5, right?
Okay.
It shows clusters.
Okay. Okay.
Very useful.
Okay. Yeah.
I got an open source implementation, ported over and working inside Trinity, and I hooked up a JavaFX GUI so you control all the variables to it and all that, and you hit go, and it bang, for thousands of points, it just bangs it out in a couple seconds.
Wow.
Right,
Okay.
which is a lot faster than the Python version. And then boom, here is your new UMAP projected version of this data. And we needed it for all this AI stuff, right? Standard operating procedure since 2018 to use something like this in AI stuff. And this was like, I finished this on like Tuesday of last week, right? 1 week out. And I kind of sat back, I'm like, I wonder what would happen if I ran this on the brain computer interface data.
What happened?
You're gonna find out.
Oh my God! You left me a cliffhanger here.
It looks, it's cool.
Okay, I'm going to be there.
But it doesn't look like, the way it clusters the data and organizes it looks different than how you would normally have it with like labeled AI data.
Okay.
Because, trust me. And I go back and I show the neuroscience guy and I'm like, can you use this? And he's looking at it and his response was, I don't know. Nobody's ever done this before. And I'm like,
there's an opportunity here.
So basically we're in a situation where like suddenly now he and his type have a brand new tool, a brand new way to look at the data that they are traditionally using and working with that they've never seen before. And none of that would have been possible if we hadn't taken the time to build up a rich framework, a rich software application with a very rich, easy to use visual interface.
Exactly.
This is why you use these powerful software development technologies like Java. This is why why visualization is important. This is why JavaFX is so important. This is why desktop applications matter.
Exactly.
Because it's not that you couldn't do bits and pieces of this on, like, let's say WebGL and like a web app. You could, but like when you start to put the sheer amount of data and all the things that are firing all at once and managing all that stuff, all the
a web engine doesn't do the job.
It's not going to get the job done. I'm sure somebody out there is going to be like, oh, yes, they can. You just don't know what you're doing. They're like, okay, fine. But how much time do I need to spend to take some sort of technology that isn't good enough, that it isn't meant for something of this scale, and then try to make it work? I'm done. I'm already done. I have the tool. It's done here. And we're looking at open sourcing it in a couple weeks. Yeah.
Oh my God, that's going to be quite an announcement.
We're still going through that process.
Yeah, I don't know.
So, but I've been told that inherently it's not going to be a problem, but there's just the paperwork. I tried to get it done. I couldn't. It just takes a long time.
I mean, what have we discussed so far? It's amazing. Because honestly, let me recap from the open software developer perspective. Not from all the stuff that is way beyond my imagination.
No, me too, I think.
But
we'll go to the keynote, and then it'll be obvious after that. You'll have a master's degree in whatever, whatever. Don't tell them that I don't know what I'm talking about. I write for loops. I write for loops and I move pixels around. That's what I'm good at.
No, but that's exactly what you're saying. We need a very mature tool to write very well frameworks so that we can build on top of them, and they are fast, resilient, reliable, and easy to extend.
Sustainable.
And sustainable.
Yeah.
So I like that of our programming language.
Yeah.
Like Java has proven to be exactly that, a very mature,
it really has.
very solid,
yeah,
performant language.
Yeah, absolutely. I mean, I'm sure, you could do something like in C#, right? You could probably do something in like modern C++. I'm not saying you couldn't.
No.
You could use Kotlin, but it's none of those languages are really going to bring anything extra to the table, except maybe performance with C++. So maybe, if you do it right.
But then let's think about the ecosystem, like the build tools, like the security, the reproducibility.
Yeah.
In that, we are super mature. That's why I'm still like, I'm looking more at different programming languages, but my heart is still on Java.
Yeah, me too.
Because we are here. We have done such amazing things.
Yeah.
It's solid. It's very flexible.
Yep,
So,
agreed. You're preaching to the choir.
Yeah. No, but the next step is like what I got from from this amazing conversation is like when you have the tools and you have a certain set of tools, now you can even ask new questions in the domain. Because usually you have like, let's look at the stars, and you have this idea and you're building the tools to look at the stars.
Yeah.
But suddenly you have this amazing technology, and now it's like, what can we look at with this?
Yeah, it's the same reasons why people will celebrate dynamic scripting languages like Python, etc. Is that, well, I don't want to worry about all the machinations of the tech stack. I just want to get the job done. That's great, and I agree with that for small jobs. This is not a small job, because you build up so much capability up front before you can even start to do real work and analysis. I think it's important. Not all problems require that big upfront investment, or at least they don't need to have that. If you can get an answer for your problem in a more quicker fashion, then you should do it. But I think we're in such a rush. I think it's a problem that as a community, as a society, the software development society, and of course the business that goes around it, we're in such a rush to make things so much easier than they were before, and to do things so much faster and cheaper, that we're consistently hitting up against brick walls of, well, we didn't invest early enough and enough time and effort to build up a critical mass of capability, and so now it's going to cost triple that to go double back and do it right, so we're just not going to do it. They're selling out next year for next quarter.
Yeah.
They want something next quarter, so they're just, and that's wrong, but it's also not my call. It's not our call. It's their call, and it should be their call. But what we can do, and what I'm trying to do here, and in the keynote, tomorrow morning,
Solid steps.
Show them the value. Prove them, put it there, it's like, bang, this took effort, this took tech, these technologies made it so we could do it, and look what we've got now. And now if you wanted to do this too, you're screwed, because you're so far behind now that you're not going to catch up for a while now. So meaning because they didn't invest up front. There is value to research and development. There's value to engineering that pays dividends later.
Exactly.
And we need to show people the value. But I think culturally, especially in the West, I can't speak for the East of the world. There's a disincentive financially to doing that, and I that's very short-sighted. And I think a lot of people kind of cave into that pressure, and they should push back.
I mean, yes, you're right. In this parts of the world, we measure even enterprises projects in months, not even years.
I know.
In other cultures, they start thinking about return of investment.
Right.
Will start at 7 years.
And that pressure, of course, forces software engineers like us to make choices that kind of force us to do things really quick and kind of on the cheap. It's like, well, I'm not going to fix this thing. I'm just going to duct tape it, right?
Yes.
And it's like, okay, yeah, it works today, but is it going to work tomorrow?
It's not sustainable.
It's not sustainable, but it doesn't matter, because to the people making the financial decisions, that they don't care about sustainability. We need, as a people, the push to be sustainable for the environment needs to also apply to technology.
Yeah.
Because at the end of the day, if everything is as technical as we say it is very quickly becoming the environment. It's affecting the environment directly. So a little bit preachy here, a little bit philosophical, but
yeah.
I think it's important to say it here at the end of this.
I mean, we have a responsibility. We have a contribution to make as software developers.
Yes.
And we're taking a decision, even if we're not taking a decision.
Yep, you're
That's
right.
For sure.
Yeah.
Well, thank you very much,
Yeah.
and I'm so happy that you were here and you
It was a
gave
pleasure.
us this amazing session, because it was almost a session. Oh my God, yes.
How long did we go?
30 minutes.
Wow.
Yeah. Well, thank you very much.
No problem.